I'm delighted today to be introducing Will South on his webinar. Will is a Passivhaus Certifier, Designer, Tradesperson, Mechanical Engineer, focusing on building fabric, moisture and heat transfer. He's built up a wealth of technical and practical experience in construction with a focus on energy efficiency, improving existing buildings and sustainable design. Will works at Etude. He's an advisor for the Passivhaus Trust and he teaches on the Coaction Passivhaus Designer Course. So Will's here to be talking about the priorities, technical decisions, compromises and outcome for his home, a two-bed Victorian terrace. Welcome, Will.
Great, yeah. So today I'm going to talk you through my home retrofit and the journey I've been through, which is walking the talk, because a lot of this I've been talking to people about on new building and existing buildings for sort of 10 plus years. Um, I'm going to whiz through it. I've got a lot of slides. It turned out there was an awful lot to say, and I've only got an hour. My focus has been around the fabric performance because that's sort of what I focus in professionally, but I touch on what else I've done as well. And I'm here now, so it is a real home, and it's sort of not finished, let's say, but livable in. So that's great. Yeah. So I'm gonna carry on whiz through. So welcome. Good. So firstly, some caveats. I think this is going to be quite overwhelming. There's an awful lot, but I will say it's taken me 3 years, probably more than 3 years, really. And I think just being really realistic about timescales and giving yourself loads of time and doing one little thing at a time. My brother always says a bucket a day. So I've been doing a bucket a day for 3 years, and this is sort of the result. Well, I say we, both myself, my partner, building tradespeople, other people I've got involved. So lots of people. So don't get overwhelmed. I will reflect on how it could be better. I always like how things will be better, but my colleague told me it sounded a bit negative. So I need to be positive up front. It's by far the best thing we've ever done. We love it. I tried to get a quote from Stephanie, but she sort of blabbered on a bit. So I've come up with cool, warm, dry, comfortable. How could we live anywhere else? So that's sort of like, really great thing. We love it. It's a bit of context. I'm in Brighton on the south coast, here fairly central. The house is a two-bed terrace house, 78 square meters from 1851. The one highlighted in white. So sort of quite dense terrace housing, quite a small terrace house. There's sort of constraints and opportunities. The constraints are we're in a conservation area right on the edge of it, which is mainly the streetscape and front sash windows. People have replaced the sash windows, but only ever with timber sash windows. With flat front with our neighbours, so the walls are all in line, so it's quite hard to you can't stick out basically from what we've already got. And the roofscape, our opposite neighbours can see our roof, so we can't go up and over. We've got a exposed to our rear returns. I'll show you on plan, but our rear returns aren't reflected. So we've got a very exposed rear return. It's quite a small space. It's got 3 or 4 exposed sides. And when we moved in, that was by far the room I'm in now, the kitchen, was by far the coldest room. So that was a bit of a constraint. And one of the reasons we bought the property is it's got a little tiny garden and a nice old shed, and we've got an outdoor loo that still works. So we wanted to keep that. That was our constraint at the back there. We've got to keep the outdoor loo. Opportunities, though, there's always opportunities on existing buildings. This is a really positive thing I want to get across. Look for the opportunities. So ours were the kitchen ceiling was falling in when we bought it. The bath had leaked for years, and there was some repair work needed there. There was repair work needed at the parapet wall at the front, all needed ripping out. There were lots of soft bits of floor, and I sort of lifted a bit up to do some bodging to make it better. And I then uncovered 100 years of other people doing the same thing to try and keep this floor rigid. And we had a bendy beam, an old sort of knock through, probably in the 60s, which needed some more structural work. Other constraints, or sorry, opportunities. One of the chimneys already been removed. 2 chimneys, but one had been removed. We've got a small floor area, which sounds like a funny opportunity, but actually it means your money goes further. So, we have less windows, so window replacements are less. We have much less exposed external wall area, as you'll see on plans, big party walls. and small exposed roof, small exposed floor. So that's sort of good. And then opportunity, we've got rear access, which is a little bit unusual for our type of properties. It's a little path you can come in through the back as well. So that's good. Uh, One other thing, when we bought it, I was looking for something I could retrofit. Other things I liked is nothing had happened in the loft. So the loft was just original, no loft conversion, no funny structure going on. Um, and yeah, that's about it. And so we came up with a brief between ourselves. Warm dry, we want to be here a long time, which justifies, loads more investment, bigger changes. Warm and dry, where we're really damp, our coastal location, all these sash windows have condensation for a very large proportion of the year. It's a 150-year-old house, so let's make it last another 150 years, or already think in that way, like be sort of custodians and pass it over to the next people. We wanted to get off the gas grid, so no fossil fuels, move to low carbon heat source, reduce energy consumption or costs. We needed to fit a table in the kitchen, which I'm sitting at now, keep the outside loo. And I've been talking about this stuff for years, and I want to, I'm now lucky enough to be in a position to be able to live it a little bit. So that's the part. So I've got two brief throughs, and I'm going to go through loads of photos. So the technical how was ventilation. So we've introduced a mechanical ventilation system, insulation, which is to the front and rear of the property, and which I'll come into in more detail, make airtight. We installed a heat pump and upgraded the heating system. We've done it as a staged retrofit over 3 years, and I've used the Enefit component method and PHPP to sort of play with things, because that's what I do day to day, and with the vague aim of certification. So that's where we've ended up. From an insulation point of view, we achieve component certification. So the missing part of the puzzle will be to get the airtightness test. And if I get the air test, then I will go, which more on that later. And you can see from this, we've got a bit of internal wall insulation in the kitchen because the neighbour's over here and we want to keep the loo. We've got a bit of external wall insulation here, and then we've got internal wall insulation at the front, replacement windows at the back, improved windows at the front. So really, we've done everything, which is an unusual position to be in. Again, I'll come back to that. We have done everything, and it's also been very bitty. So a lot of these bits of work have been really small quantities of material, which in itself means things are more expensive and it's more challenging. So that's the technical. So that brings us on to practical. We'll come back to PHPP. So we've put a lot of money into the house. We bought it relatively good at a good price because of some of the works that needed doing and because of the timing was very good. So we've got extra money on our mortgage for some of those repair works, all our savings, and we borrowed a bit from family, which gave us 180k budget, which is a large proportion and a significant proportion of the value of the home. But probably recoupable in the value of the home, I would have thought. I don't know, but I would have thought it is over 10 years or so. We've prioritized the big works. So wherever we've been worried about money, we've done the thing which we couldn't do again, which mainly was things like floor insulation. And a good sort of old-fashioned building phrase is a good hat and good boots. So do the roof first, make sure you've done the floor and any damp proofing works, and then work your way in. And that's a really good sort of mantra to live by. Maybe a good hat and good boots and a good pair of lungs. So for ventilation, maybe I'd add that one on as the last bit. I did a DIY design, DIY planning application, lots of which I think is in reach of people who are not in the building industry, with a vague bit of technical interest. I think you could do a lot of what I've done anyway. I got a building contract with a local company, an AECB member, Alex Hunt, 100, which was value about 120k. It went up a bit because of changes, us changing our mind, but that was the value of it. We got some VAT relief from the energy saving materials and heating equipment bill, or whatever it's called, which was quite difficult to do. I find that really difficult to do. We had to separate everything into different invoices. People were really nervous about it. Don't muck about with the VAT man being the sort of euphemism. And then I did DIY air tightness measures and DIY ventilation install. And then lastly, practically, At one point, our neighbouring property became available, and I managed to get it on a cheap rent, and we moved next door, which enabled a 5-year plan to become a 1-year plan. And we did the floor insulation basically. So that's all practical things which help. Actually, this is 90% of it. This is actually the difficult bit. How am I going to do this practically? How do I move around my family, circumstances, etc. I did use PHPP, as I mentioned. So this is the Passive House Planning Package, an energy calculation. It's powerful. We use it in our work. I think it was very useful, but actually, I don't think it's necessary for this sort of property or this sort of works all the time. And ultimately, the bit that was useful was a glorified area weighted average U value calculation, which is this bit in the verification tab, which looks at different bits of your house en masse and gives you some targets to meet. So the key ones being internal wall insulation, external wall insulation, roof, floor, gives you an area weighted target to meet. And that did push me a little bit. It made me do different things. So that was useful. But other than that, really, it just gives you a number at the end and you could measure it. So that's my sort of take a little bit. Great. So now I'm going to get into it, what I've done, roof, floor, etc. So this is the front roof, existing gutter, the sort of depth we've got. We pulled it all away and found that none of the rafters were sitting on anything, which meant some additional work. So I came up with this detail, putting in an extra structural bit and then packing the insulation from inside and then going for a vented lead roof. So that's at the front. The tricky bit is getting air tightness. So at every single step, I've been thinking, okay, what's the air tightness strategy? How can I tie into the next bit? In this case, I went for a membrane across the whole of the loft floor on top of the joists. And then I've come through awkwardly into the ceiling in this location, tied into the wall. So that's really awkward in practice, but it meant I didn't have to muck about with any other ceilings and internal walls. That's what it looks like in practice. So I did a bit from above, and then when they dropped the ceiling internally, I did the rest inside. And then this is the structural beam that went in, and we hid that with the internal wall insulation. So all a bit messy, but that's what it looked like in the end. So nice, good hat, not good red roof. That's not going anywhere for a while. The loft, it was a new property, so it's not too full of stuff, although they did leave us a bit, didgeridoo, for example. So clear the loft. There was some insulation, most of which was in black bags at the back of the loft, so adding to that. We don't have any eaves, and I wanted to do external wall insulation at the back. So while we were doing this, I extended the rafters at the back, which sounds like a lot of work, but actually for a roofer, removing a few tiles at the bottom, pushing it back and adding a bit more felt was surprisingly lightweight. So that's what it looks like outside, and inside they unfortunately decided to go alongside the rafters, which made things awkward, but there it is. And then air tightness on top of the joists throughout with a bit of insulation underneath. And then importantly, I need to make sure I've got enough insulation on top of that so that my dew point is near enough the internal temperature. While I was at it, I had one duct that I needed to run across the whole property, so I did that at the same time. And then I've got 450, 400 mil in some places insulation, and I used wood fiber board in the eaves to get that vent connection so that the loft space is still ventilated underneath the felt. I got a bit of access in the middle, so I can do a bit of storage, which I made out of the timber that was already up there. So there's an extra batten onto the joists, and then I built that up. So I did the loft insulation, but I didn't do anything else really. I got the builders did that. This is then the rear return roof. So I've talked about the front, the loft, and then the rear. And the rear, I did something a bit odd because I wanted to squeeze a heat pump in. So I lifted the insulation up to the pitch level and introduced a flat roof. And this is the long section through the property. So you've got this section which is pitched, and this section which I turned into a flat roof. And this is sort of that in 3D. And also showing where I sort of was thinking about where to put the heat pump. So this is the property is a 3D. We've got not much space in the garden, very near neighbours, and we really like the garden. So I wanted to get it out of that. And this is where I went for eventually. Neatly, it's right above this space, which I've used as the plant area. So my hot water tank is directly underneath the heat pump, which is neat. And there's some other locations. Well, maybe else I could have put it here. I think my neighbours probably, lots of them have got other types of roof, flat roofs at the back. I think a lot of them might end up putting it on the roof there. Maybe if they don't use the garden as much, they could put it in the garden. I think the front's probably out, but it could be possible. Could be possible. So that's on the street. We've got that little awkward bit. It's on the road, maybe. So those will be options. So this was the practicality. I wanted to reuse the rafters, but we quickly discovered that they were too short. The wall had moved and they weren't really sitting on anything. So we had to replace those. And we replaced the rafters and then used a sort of Larson truss, dropped the ceiling and did full fill cellulose with OSB inside, wood fibre outside. And this was very familiar. This is the sort of air tightness works and that bit of flat roof. And then this is what it looks like at the end. So getting the heat pump on the roof. Once I'd done this and very much committed to it, Andy Stanton told me that he had a heat pump on the roof and he could hear it and it vibrated. And there's some small print in the Valent catalogue which says, put the heat pump on the roof as long as it's a concrete roof. And so I was like, oh, God, that could be nasty. So I bought some more expensive acoustic feet, vibration damping feet, which are sized to the mass of the unit. And then I introduced more weight basically to the roof structure in the form of some lintels. So that's what I've done. You can't hear it through the roof. I've got solid 250 mil of cellulose, very rigid timber frame, this mass, the acoustic isolation feet. You hear the heat pump inside when it's really going for it, but it's all air movement. It's through the wall. It's not vibration. Good. Next up, I disconnected from the gas, which was a very exciting thing. As this is gas disconnection day. It cost £1,000 to disconnect from the gas grid. So I suspect that that's a barrier that needs to be removed at some point. I don't expect it to happen anytime soon. Maybe if 10 of my neighbours did, SGN might need to redig their rework out how they're going to afford to maintain the gas grid potentially. But that was good. So monumental day. And that was all part of the floor. So the floor was the next bit. Lots of the floor was not supported. I had 3-inch joists underneath the floor, supported on very, very, very regular walls, which meant that if I wanted to insulate within the joist, I'd end up with very little. So this part was in really good nick. Other parts had been replaced. Other parts were shot. Actually, there was actually mainly because there were so many pipes going through and cables that there was no joist left. They just cut through them all. So I took the decision to actually take it all up and put in a solid floor. And I was I don't know, lucky, or I don't know what. Yeah, maybe I'm lucky that the floor depth, the floor void depth, was roughly 300 mil, dropped off a bit towards the back and relatively flat. So we could take it all up and I'll just skip ahead to, oh no, I won't, I'll just skip ahead. So we could take it all up and put in this solid floor. When we did that, we found that the internal partitions were all resting on a 12 mil floorboard. So they weren't actually supported at all, and they were brick, not timber, or they were timber frame with a brick infill. So we had to remedy that, which is unforeseen. We ended up doing a sort of block on edge and then a thermalite block to support it all. My floor build up, I went quite a little bit off piste with this one, so none of it's structural. There's nothing sitting on it now, and the build up I'm on chalk, which drains very well and is fairly solid. Actually, at the front, it's solid chalk almost. So we basically compacted what was there, moved it around a bit, sand blinding, EPS, then a damp proof course, and then a screed with some reinforcement in it. But actually, I didn't use metal reinforcement in the end. I just used some plastic trays and then a floor finish that's bonded to it to give it a bit more rigidity as well. So that was the sort of build up. And critically, the foundations don't look like this. They're all over the place and brick and chalk block. I'm bungarouche, which is brick structure around the edges and then essentially a sort of lime, very crude lime rubble wall. which I actually quite like. I like it. It was a cheap material of the time, and it's really of the earth from around here. The foundations were very rough, and it's very vulnerable to moisture. So I've included some lacquer beads. They're sort of aerated clay beads around the perimeter, which meant I could cope with all sorts of difficult foundation, and also mean the lower part of the walls can drain moisture from it internally and outside, so the water can escape. That was sort of the key bit there. So this was the floor stripped and the wall supported. And then this is the sort of insulation going in, and we filled this perimeter bit with the lacquer beads. And then some underfloor heating pipes, and then screed and this finished floor oak. I really wanted to bond all the old floorboards back on, and I kept all the boards and I kept them inside, and I was so careful with them all. And then it came to it, and essentially everybody told me that it was a stupid idea to stick old pine floorboards to a new floor, and they would invariably move and shrink, and it was a nightmare. And they were cut all badly, so they would have just come up at the edge. So I regrettably ended up going for a new floor, but it looks great, and I've got used to it. It's fine, he says. It's good. So that's the floor, roof, floor. So the walls, we did a bit of external, bit of internal. On the external walls, we removed the weak render, which ended up being most of it, and took off the thin cement skim that had been put on most of it, most of which was actually falling off already. And then we used actually a cork external wall system with Baumit products, lime products. I went for cork mainly because the builder had just used cork and was really keen, and they had a supplier, and the material was a little bit more, but as I said, we haven't really got much of it. So actually, it was all in the labour cost and the Baumit products. So the actual insulation material cost didn't make much difference. I like the fact that it was going to be water resistant whilst we were doing it. And it didn't, and also over time, if the render does crack and water gets in, it doesn't mind. It's not like mineral wood would absorb it. EPS, I'm not really sure what would happen. It would slowly absorb it over time. Wood fiber would absorb it. Cork, it felt like, okay, that's gonna shed it, and it felt a bit more robust. But actually, any of those options would be fine. And at different points in time, I sort of thought I was going to go for different ones. So that's what I ended up with. This is what it looked like going on. And then a bit more detail. One challenge we had was where you did chip the edge. Apart from stuffing more cork down the crack, there wasn't really a natural way of being able to mend gaps. So that was a bit awkward where the wall wasn't flat and the boards didn't sit flat. I put on 140 mil, which was led by two things. One was the area weighted U-value calc that I needed to achieve. And the other thing was a window reveal. So where my rear return comes in, I needed to miss the window reveal. So that's what it looked like. And then we've got this drip detail, and below the drip detail, it's EPS. So just sort of to resist water, and it's quite a dense EPS, which will go in. I included the drip detail, but then I changed my mind late on and ended up refilling it and actually bringing the render over that to give a more traditional detail, because it's not very exposed, and it just looked a bit silly with this drip. So that was what I did. I was quite pleased with my door threshold detail. We've got a level door threshold. There's the door. This is inside the screed, and then this is outside. And I used some compact foam. They're actually two bits of 50 mil. So it's a bit higher than this. And I just offset them, which gave me this little step to put the external finish, to bear the external finish, because it's quite common to have nothing to sit that on. So just by offsetting the compact foam slightly, we had a little step, which it's a bit of paving slab, but it could be pavers or anything, can actually sit on rigidly, and it doesn't have to, when it's bridging, this bit of insulation. So I was quite pleased with that. And then on the windows and doors, the insulation comes over the face of the frame, and then there's some infill around the opening, expanding foam basically, which is a bit of a compromise, but it means it's really easy to install. The windows could go in quite early, and it's fairly robust. So that's those, showing you that one. That's the external wall insulation. Internal wall insulation, we took off the plaster, and on some walls, not all walls, it's gorgeous. And Stephanie, my partner, was like, this isn't actually the best one. There were some really lovely walls. And Bungaroos has got a bad reputation for being bunged together, but actually it was incredibly neat. Chalk on the inside, flint on the outside, gravel mixture with lime, really well built, really. And then these brick coinings at corners and around window reveals. Very sort of predictable. Once we sort of saw that, we knew what we were getting. Um, some of the walls they'd been cement and damp proof. This one on the left, you can sort of see, and we decided not to touch them, which is a little slight risk moisture wise, but not a big one because they're not on exposed walls. And I think we'd have done more damage than good if we'd have taken it off. So that's what that looked like. You come across details like this. So this was just all boxed in. It was a thin bit of timber over it. And this is really challenging to work with masonry. You get this on brick buildings as well. How do you deal with all these complicated details? And it's actually one of the reasons I quite like a wet system, so wet applied. So we used wood fiber internally, and I used an insulated lime plaster or lime render to daub out these difficult details. And this was the product we used, which is a Baumit product, but there's others. There's loads of now products with sort of cork binders or EPS binders, and they're called like insulated plasters or insulated renders. And the nice thing about them is you can apply up to 70 mil, this one, in one coat, which means that suddenly flattening off areas is much simpler. And once we got used to the guys got used to working with it, it was great. You could sort of flatten off areas much easier. The important thing with this sort of construction is you don't want any air gaps between the insulation and the wall. You want it all to be sort of one piece, and you want to use the lime bonding coats. So that's what we've got here, making sure that all those are really well bonded, fully stuck to the wall. I've got 80 mil wood fiber, and then again, because of my slight NFIT by component, I need more than 10 mil insulated plaster on the inside of that, which I've got most places. Some places probably 5 or a little bit, and other places it's like 40. So yeah, that's sort of there. I looked at some of the details, so just the techie. Again, you don't have to do this, but because I'm in it, I did. So this is looking at the join between external wall insulation, which is this bit on the right, and internal wall insulation, which is this bit here. And you might want to return the insulation down this face to make sure that you don't have a cold spot and a risk of mold growth. Because the bungarouche is solid, but it's got cavities, and I guess the conductivity, I tried a few conductivities, but even with relatively high conductivity in my climate, I was seeing temperatures of sort of 15 degrees under most conditions. This is 0 degrees outside. I tested it -5 as well. So I sort of just took the decision not to do the returns, which was a bit of an oversight in one location. It's one location I didn't think about properly, where the heat pump is. There's a parapet that sticks right up and then joins the wall, which means you've got this massive cooling fin. And I think that area is probably the weakest, and I haven't done a model of that. So it's just showing you that. In my location in Brighton, it's probably okay. This was the finished wood fiber, importantly taking it through the floor to meet the bit below, and the detailing. I think all in all, it's not much more disruptive than replastering or having to mend some plaster. This room in particular was done when the rest of the house was finished. It took less than a week to go from plaster and it looking finished to being ripped off, wood fiber on, replastered, good to paint. So yeah, I think this is sort of definitely something that's repeatable and felt quite doable as when we're living in the home. Most places where I needed a fixing, I let in a bit of plywood and put some big concrete screws through it into the bungarouche, so that I'd have an easy fixing for radiators and for the kitchen units. I did that. Some places I forgot for internal wall insulation, so for putting up shelves became a bit awkward. But you can get these fixings, which are like massive plastic rule plugs, which screw into the wood fiber. And they seem pretty good. They're holding so far. They've got all Steph's box files on. So yeah, one oversight, but you can overcome it. So that was useful. I replaced the windows, which I'm not going to go into too much. I've done triple glazing at the back, mainly for surface temperature. So I'm sitting next to a triple glazed window here. warmer surface temperatures mean you can have a lower internal temperature and still feel comfortable. So it's 20 degrees in here. I'm comfortable. Before retrofit, we had it at sort of 24 degrees, and when we were working from home during COVID, and we were still feeling a bit cold. So that's sort of it in practice. The reality of replacing the windows is it's very disruptive. You rip apart the wall, but again, it took them a day to rip out all the windows and get one in, so it's surprisingly quick. And then that's it finished. That's where I'm sitting now. Front door, I replaced the front door with sort of view of having some solution for historic properties where people were very worried about what their front door looked like. So I bought a Passivhaus door blank and then had a joiner face it with a tricoya and recess these panels and put in moldings and things. So it looks like a traditional door from outside. Actually, it's 70 mil of insulation, double sealed, airtight door. Well, airtight in inverted commas, I'll show you in a minute. And it's got a triple glazed unit above. It was, it was quite expensive, but if you buy a new door, even for a new property, they do seem to be expensive. So yeah, we're really, really pleased with it. And it's got a very simple locking, which is actually 3-point locking mechanism. So it could be a solution. It's quite a lot of hassle. I'd probably tell people how to do it, but I probably wouldn't go through it again myself. I would on my own property, but to go through and do the importing thing was quite stressful. So yeah, that was good. And this is my neighbour's door that I copied. So we measured the reveals, and there's others which don't have this second one. And our letterbox is a small metal box just around the corner. You can't see it. It's a white box, which has not been a problem. In fact, somebody admired it, which I was quite liked. So great. So yeah, windows and doors. Next bit on some services. So I have got mechanical ventilation with heat recovery. I think ventilation is fantastic. Love your MVHR. I did this install. Last time I did sort of my own design and kit of parts, ordered bit by bit, and I did a semi-rigid system in my flat. This time I used a kit of parts from Green Building Store, which I've done before in somebody else's house, and it just gives you a bit of reassurance. It's the quietest system you can get, and for longevity, I think, I feel like I can clean these ducts over time. It feels really robust. So this is the system. The unit squeezes into this plant room, which is nice because it's right next to the extract for the bathroom and right next to the extract for the kitchen. And then all the supply is in the old part of the house. And I had to go through the bung rouge wall once, so that was nice. That's the sort of plant room, and I set the unit off the wall by quite a long way so that I could get ducts behind it, which makes the sort of finished install quite much neater. And then my ducts to outside just go straight up through the flat roof. The two bits internal distribution which were difficult was I had to come through the very thick wall and then up into the loft, across the loft, and then on the other side I came down and I had just added a bit to the chimney, which is something I borrowed from Bob Pruitt and Pruitt Bisley, and just boxing in, and now this is plastered. You don't notice it, and actually interestingly it puts the fireplace back in the middle because of where the chimneys run. It's offset, so now it's in the middle. Good. And then this is the finished plant cupboard. It was a real squeeze. I knew it was going to be a squeeze, but it really was a squeeze. The main reason for that was that the heat pump comes with so many extra bits that they needed to squeeze in, some of which were expected, others which weren't expected. So extra wiring centers, extra valves, which actually I think we didn't really need. And the dialogue between the plumber, the Vaillant, the supplier, and us was really difficult to understand actually what was going to be installed. So that was quite a lesson. There's got to be a better way of routing pipe work. My lessons would be buy a cylinder that's got an integral expansion tank. They're available. It gets rid of one of these, and means you can it takes up loads less space and less pipe work. Yeah, other than that, it's all gone in, which is good. And I've got really short ducts to outside, which is great. Cool. So ventilation, air testing. I have air tested the house. I haven't finished, so I haven't done anything with the front windows, which is fine. But I knew there were some leaks, and I wanted to put some numbers to it and work out how bad it was going to be. So I've achieved three. I've got three air changes. I've got test result three air changes. Misha from the AECB came to do it. He was also in Brighton, and we had a nice afternoon of walking around and working out where it was going. Can I do better? I think one air changes, which is Enefit, is going to be a real push, but I will try my best. Will it make much difference? Probably not practically. It's really good already, and the doors and windows are excellent. One lesson was my really expensive door. I didn't commission it properly. I hadn't adjusted the hinges properly, so the seals around the front door were actually really leaky, which was yeah, not ideal. So yeah, but I can reflect that. So results all on one page. Haven't got that long left. But to leave some Q&A. So first of all, temperature wise, we used to heat on a time controller, and we'd go up when we were at home. We'd just crank it on to 22, 23. I think yeah, we once hit 24 in one room, but most on average it was about 18 degrees average cold when you got up. Now thermostat's at 20. We just keep it at 20 the whole time. Initially, it's just so I can compare it to my PHPP calc, which is at 20 the whole time. But actually, it's fine. It's really good. So we've just left it like that, and it means loads less hassle. Gas has gone from 158 kilowatt hours per meter squared per year to nothing. So great. Got off the gas grid. Obviously, we've added some heating. Interestingly, the electricity demand has not gone up that much. I think this is only it's like 1.5 years of before retrofit and 2 years since retrofit, which includes works and stuff. So it's not that reliable. But even normalized for weather using the heating degree days, electricity's only gone up a bit. So I suspect it'll go up a bit more, but that's the energy use intensity, 39.2. So up a little bit. Operational carbon down 86%, mainly through moving to electric heating, but also through the energy efficiency. And then the cost has gone from £2,500 a year to £1,000 a year, roughly. I'm not going to be recouping my 180 grand very quick if you're just looking at energy bills, but obviously we've put value on the house. It's a much nicer place to live, and would I do it again in a heartbeat? It's great. And I think that the difference in terms of living and comfort is one of the bigger things, actually, that we're not doing this for energy and carbon savings. We're doing it because it's really lovely to live in, much like people drive very fancy cars or use very fancy computers or telephones. They're not doing it because it's the economic thing. They're doing it because they're there all the time and it feels really good. It feels much better. So that's the point more probably. But numbers are there. Then in some graphs, so the energy use intensity, sort of adding gas and electric, which isn't ideal, but there we go. We've gone down from pre-retrofit to this is what current will be when I've finished. Sorry, this is then the actual uncorrected, so it's slightly less than the predicted. And when I interestingly the corrected, so when I've added on the extra, it was a bit warmer the year I monitored, so the extra heating that I would have had, it's really similar for energy use intensity. However, the space heating demand, the difference between the actual measured and the corrected is quite a lot different. There's a lot more, it's a lot higher. So I think that's probably we're using less equipment. We haven't got as much electrical gains, but our heat gains are probably higher. So PHPP is overestimating how much heating energy we'll need on first look. And my current progress, because we haven't done the front windows yet, the space heating demand is 65. Once we've done the front windows, it should be scraping 40. And if we bring the air tightness down to about 2, it'll be around 40. Actually, interestingly measured, we're almost there already. And I remember I'm running it at 20 degrees. If I correct it for a slightly warmer year, it goes up a bit, but not that much. So yeah, interesting. Sorry, down a bit, up a bit. I can't see because my face is in the way. Cool. So that's with all the measures I've done, which is obviously quite a lot, and not everyone could do that, and not every home's going to do that. So I just played around with it. What would happen if I just did less measures? So if I only did the loft, 450 mil of insulation, and replaced all the windows with double glazing, not triple glazing, this would be where we'd get to. So that's where I am now. Lofts and windows only at 20 degrees. I'd be at a energy use intensity of around 52. And if I got the same comfort, which I can sort of roughly work out by increasing the temperature, then maybe I think it works out about 60. So, still pretty good. And importantly, the heat load would be less than 6 kilowatts, well within a heat pump's range. And I wouldn't have to upgrade my supply or anything. I'd probably have to change the radiators, but I could do a heat pump. So with much less fabric measures, it would still be possible to get, the majority of the carbon gains and some of the energy savings. What I wouldn't get is the additional comfort and that last little bit. So that's some comparative numbers. So that's me for the house. I will carry on looking into it. I was sort of thinking about what would be next. What does this mean in a way? Because it's just one house. What does it mean for us and the UK in general? Um, Often what we're focusing around and talking about is sort of social rent, council housing, maybe the private rental sector. But actually, 30% of properties in the UK are owned outright and don't even have a mortgage on them. So that's a lot of properties. And there's a 30% more that are owned with a mortgage. So all those people could do or could start doing what I'm doing because they want to improve their home or because they want to get off gas, install a heat pump, whatever their motivations might be. There's a lot of people there who could do it. So I think it's really important that anyone who does this, and this is what the AECB enables really well, shares their experience with neighbours, with their builder, says, oh, to the builder, oh, why don't you suggest to other people who are having a flat roof that they have some insulation on it? It's really easy. Those sorts of things. Sharing the details, sharing the lessons, talking about it is really, really valuable. My main takeaway is that the value, the difficult bit is the practical bit. Like, oh, I can't imagine taking the paint off the wall, ripping out my lovely kitchen. It would ruin my life. So the value of having an empty home or this change of ownership or moving into a new place is really, really valuable. And we should really leverage that and try and make that the time we do things. Um, I was able to move next door. I think even if, move not being in the home means things can happen loads quicker. You can do it when you're in there, but it means there's more compromises. So that's the challenge. And lastly, I'd say if you're watching and you're thinking, oh, maybe, yeah, you can do it. There's loads of resources out there. I think a lot of this is within, as I said, even minorly technical people's ability. Some things I wanted to point to, the retrofit.support website and the retrofit pattern book has got details and specs that you can, at the very least, show your builder, show them what you're sort of intending and agree on what they might do. There's the National Retrofit Hub, which is collating a lot of information for UK at scale, and then obviously also the AECB. Become an AECB member. There's the knowledge base. There's the retrofit course. They're looking at different retrofit standards as well. It's definitely a sort of place to watch. Great, that's me.
Well, thank you very much, Will. That's been amazing. And we've got loads of questions, as you'd expect. Let's see if we can rattle through them. First question was, how did you get, this is when you're describing having a membrane that goes through the roof at the loft level. Someone is asking, how did you get through the joist when laying down the membrane?
Yep. So I showed a photo of that, but I probably went over it too quickly, which I can skip back to. Um, So these are the joists coming through, and the detail I showed it over the top, down, and then underneath. So what I did is I laid it over the top, and then I made a slit, and I carefully dressed it around each joist, and then I taped the membrane to each joist at the top. And then when the ceiling came down, I dressed that down. It was dangling down into the room below, and I dressed it underneath, and I taped it along here into the wall.
Amazing work.
Yeah.
And next, Next thing, we've got a lot of questions, so we're
Okay,
moving on
okay, yeah, go on, carry on.
to how did you get the heat pump onto the roof?
Great question. So we had scaffold out the back and it fits through the bedroom window. So it came up the stairs. Uh,
You
and
joke?
I had four people there. I was thinking it's a four-person lift. And actually one of the lads was like, and got underneath it at the back and took the heavy end, and then someone took the light end at the front, and they lifted it up, two of them, which I
How
was
heavy is it then? Is
they're a lot. I can't remember off the top of my head, but they're definitely in the order of 100 odd kilos, more than 100 kilos. And they're
wow.
all because the fan end's light, the other end is very heavy. So
Mhm.
it's really awkward to move. Yeah, but yeah, the builder suggested putting a roof light in the loft to get out to it easier because that's the maintenance. It's not ideal. It's not ideal, but which is a good idea. So I will probably do that at some
Well,
point.
moving on to that, actually, there's a question about that. How has your Aerotherm Plus air source heat pump performed? I recently had one fitted
Yeah.
and it was faulty out of the factory, had to be swapped by the manufacturer. It's now performing well, he says, but he's interested to know what yours was like.
Yeah, so mine was completely fine. Worked out the box. I have got a lot of data. I've got Open Energy Monitor, and which is brilliant. If you're going to do a heat pump, do the Open Energy Monitor heat pump kit with a heat meter. Gives you loads of extra info. I could have had another hour on that, but I focused on the fabric. So I was quite interested. I went for a normal bit plumber. I tried not to do too much on it because I was just interested in the process, what you get as a homeowner. They made the system too complicated, got different valves, zones for underfloor heating and radiators. But it worked out the box and it gave me 3.2 COP for all the first year, and no problems. Um, I've fiddled with it since and made it one open zone. So I've just got one zone, just disabled everything and rewired it. So it's one zone, just running at underfloor heating temperature, which is fine. And now I'm getting, 4 COP. I'm very much down the leaderboard on the heat pump and I'm trying to climb up. So I think I'm 3.6 at the moment and I'm hoping to get up to the high threes, if not four. So yeah.
Well, you fantastic. You mentioned underfloor heating, and there's a question about that too. Um, Someone asks, was the underfloor heating installation worth it? And if so, from what space heating demand does it make sense to install it? She says, I understand if heating is not a constant need, a system like underfloor heating is not efficient due to the time needed to warm it up.
Good question. Difficult to explain quickly, but your underfloor heating works well constantly with an air, oh, sorry, the air source heat pump works really, really well if it's working a little bit a lot, if you see what I mean. So if it's working, just trying a little bit, but over a long period of time, it likes that. And that matches really well with underfloor heating. And the other thing the heat pump likes is low flow temperatures, so a low temperature difference between outside and what it's trying to provide. And again, with underfloor heating, you've got loads of area, so you can have low flow temperatures. You could just have big radiators as well, that would be fine. I could have gone for big radiators downstairs, it would have been great. Because I was already lifting up the floor, and for my property with a ventilated floor, a really big change was going from suspended timber ventilated floor to solid floor. That's been a complete game changer. Suddenly, my floors are not drafty, it's warm, it's solid. So because I was doing that already, it made a lot of sense to do underfloor heating. Um, you need some insulation below it. It does work. It's just that you're also heating the ground. So it's much less efficient. You're wasting lots of energy. I mean, I say wasting, you're just using more energy. It's probably going to be better than whatever you've got now. So yeah, you take your pick. Um,
Fantastic. Someone asks, on the gas grid, you disconnected from the gas grid. Did you look into switching supplier before disconnecting? They think that Octopus might be able to do it for free.
Possibly they can now. At the time, they couldn't. I was on Octopus, and it's complicated because you have to. It's not only your supplier; it's also SGN, the network provider. So your plumber has to do something, the supplier has to do something, and then the gas network operator has to do something. And at the time, they weren't paying for the gas network operator, whereas maybe they are now. I don't know. So the cost was actually had to pay Southern Gas Network to disconnect. The
And
last
did it go, and a follow-on question, Did you get it cut back to the street for that 1,000?
Yes,
So
yeah,
what?
it cut back to the front gate. So there was another driver for me because all our meters are in the hallway, right in the middle of the hallway. And I had the huge gas meter, and then I had a huge old Economy 7 time meter and an old electrical meter. So there's a lot of benefit in getting rid of the gas meter. So that's if
Oh, I
you
see.
took it
Right.
back
Yeah.
to the meter and capped it at the meter, it would be cheaper. But I actually had the meter removed and it get taken back to
To
the street
to give you some more space.
to give
Great.
more
Great.
space. Yeah, yeah.
Um, uh, did you consider using glass, a blown glass insulation in the floor with a limecrete slab? And if so,
Yeah.
is there a reason why you didn't do that?
Yes, I did. I did, and it's probably a more robust, nicer solution ecologically, and probably better for moisture. My reasons were I didn't really have enough depth, so the foam, the glass bead, or you can actually use the clay beads as well. Their thermal conductivity is much higher. So to get the same performance from the floor, I'd have needed probably double the thickness, which would have been digging out and taking away a lot of material. I needed a lot less EPS. It was still quite borderline. It would have been better to have put more. And then on top, the screed is much thinner. So I've only got 70 mil screed, which for the underfloor heating reasons, getting good efficiency from your underfloor heating. Ideally, I'd have had sort of 50 mil screed would be better or even less. But because it conducts heat out the pipes better. But with Limecrete, you need lots more than that. So that would be the other reason. I just need more depth, basically. I didn't have.
Um, okay, next one.
Cost,
Thank you very
sorry,
much.
also cost. Mine were screed in a day, local lads, yeah, pre-mixed screed pumped in from the front. It was cheap.
The now going to the bottom of the wall, the exterior insulation EWI at the bottom of the wall where you've got the
Yeah.
EPS. Someone
Yeah,
asks, how far does the EPS follow the wall underground
good
externally?
question. Yeah,
And could you
detailed like
model it?
that. I'm trying to find a photo of it. Uh, Here we go. This one. So yeah, talking about this bit of EPS. So the
Yeah.
100 mil, that bit goes to the foundations, which is this. So this we raised the level here. This is all raised to the kitchen floor level, and there used to be 2 steps down. So it goes about 300. No, it must be more than that. Probably 400 mil below finished floor level. But that's only because I already had that depth. I mean, sensibly, you want to go below the bottom of the floor insulation, whatever you've got. If you haven't got any floor insulation, then as deep as you can, go down to the foundation. Is sensible.
Um, Following from that, actually, an interesting uh, question here was, did you consider IWI throughout rather than using mixing EWI and IWI? Was it because there's a space consideration?
Good question. Yes, but only the main reason is the kitchen. So where I am now, it's narrow, long and narrow. So probably the only reason is so we could get the table in the kitchen, which was in my brief, if you remember. Otherwise, we could have gone internal wall insulation throughout. Actually, that's not true. The other reason is that external wall insulation gives us a bit better performance because we can get more insulation in, and we also
Mhm.
bring all the bungarouche inside, sort of protect the bungarouche. So
Aha.
the sort of big compromise move was not doing external wall insulation on the rear of the rear return where the shed is. That was the sort of compromise. So originally I actually had it on 3 sides, and then I moved to having it on 2 sides. But yeah, internal wall insulation would work. It would be slightly worse performance, slightly less space. But because we took the chimney breast out in the kitchen and bathroom, we on the bit that had been net the same amount of floor area.
Speaking of which, again, you mentioned a fireplace, and did
Yeah.
you retain the fireplace then?
So we have 2 chimneys. We've taken one out, and then we've got the other one. When we moved in, there was a wood burner, which my partner loves. So we have the wood burner, and I occasionally permit a tea light to be lit in it. And then once a year, we have a ceremonial log. No, I'm joking, but we occasionally light the wood burner. So we have got that one chimney, and there's 2 flues because there's a flue for upstairs and a flue for downstairs. We've lined the flue for downstairs and put those clay beads in, lacquer beads, and then we filled the other flue with the lacquer beads and blocked it as airtight. and it's vented at the top and capped at the top.
With a mix of IWI and EWI, you were talking about the thermal bridges in the presentation, but did you notice any of that come through? Did you notice something internally? Did you get any damp patches?
No,
Anything
no.
like
So
that as
that's
a
why I was
result?
checking with this is, was I going to get any damp patches? Should I worry about it? And my sort of temperature and the FRSI and things were all fine. So I thought, no, I don't have to worry about it. In a colder location, or what's happened in another location is geometrically, without me really thinking about it, there's an extra bit of wall that sticks out here. And so there's a lot more surface area, which means this bit of wall gets colder, which was unforeseen. And it sort of, luckily, it's in the landing. If it was in the bathroom, maybe I'd have a problem. Um, yeah. So, but elsewhere, nothing. We've got MVHR, so the humidity levels are much lower as well. We'll be monitoring that. We've got maybe, uh, at the moment it's been a bit dry, to be honest. We've had sort of 45% down to 40% occasionally when it was really cold humidity. So that's really low. Yeah.
Uh, Next question. How did you deal with the existing, well, going back to the chimneys, how did you deal with those chimneys in terms of air tightness and thermal bridging?
So they are a thermal bridge. The masonry goes through the roof, but we filled them. So the one that's operating has got a small flexible stainless steel tube in it, and then all around that there's these clay beads, lacquer beads, or you could use vermiculite. I quite like the clay beads because they feel like if they get wet, they'll dry again. Whereas with the
Mhm.
vermiculite, I'm almost a bit like, maybe it would stay damp. So that's what we've used. And then I've capped them, I've made it airtight at the bottom completely with a membrane. Um, and there's a wooden panel there. And I don't know, maybe I'll put a moisture meter on it at some point, but in theory, it could get damp at the bottom of there. In practice, I don't know whether it will or not. Chimneys are very well sealed. They've got a lead flashing and yeah, anyway, yeah.
You
Houses
mentioned
are damp. They get wet and they dry again. That's what happens. It's all right.
you mentioned that the air tightness was three air changes, and you also mentioned that you were planning to improve it. How are you going to improve it?
Yeah, so one is I'm going to commission my door properly and close
Oh
up.
yes.
And then there's my loft hatch. I homemade a loft hatch, which it's a normal loft hatch, but it's got EPC insulation stuck to the top of it, and I hadn't put the rubber seal in. So now I've got a rubber seal and sort of simple what are they called? Locks that you'd get on a locker in a changing room so that it pulls it shut. So the loft hatch is shut. And then the last one is the front window sashes, which were done probably, I don't know, 10 years ago with some draft seals. The sashes are going to be replaced because they're all completely shot. They face southwest. And that's the last thing I need to do. So once the sash windows have got new seals on them, maybe I'll improve slightly. I'm not going to go to a casement replacement because it doesn't really feel in keeping with the house and it's useful ventilation for us, particularly in the front bedroom in the summer. It's, you can open top and bottom sash, you get a lot of air movement. So, yeah.
Um, Fantastic. Bertie Dixon says, uh, I didn't see a buffer on the heat pump circuit. Has that worked okay? You
That's a
spotted
great
that.
question. How does someone spot it? I can't
How
find
does
the
someone
thing
spot
again
that?
when I'll have to go to the picture, but I can't find the. So the answer, that's a great question because there's quite a good answer. So there is a buffer vessel. So there was a buffer vessel and it arrived, and I was like, there is no way that is going in. My heating system definitely has enough volume. I've got big cast iron radiators upstairs, and there's underfloor heating downstairs. But Valent wanted a buffer vessel, which is
Well,
fine.
a
So
buffer on the
actually,
heat pump circuit. Oh, well, I suppose
on the
no,
heating
that's just a,
circuit, yeah. So when
well,
it shuts off, when all the radiators shut, or if the circuit's shut, there's enough volume for the heat pump, and in defrost, it's got enough volume,
oh,
etc.
okay.
Yeah.
Right.
So I ended up there's a radiator the other side of this wall, which is an old cast iron radiator, which was here before, and I ended up measuring the volume of it. And my builder said, or my plumber said, it's going to be 2 litres or something. It's never going to be enough there. And I filled it up a Pyrex jug at a time, and it was 18 litres, and they accepted that as my buffer vessel. So that's plumbed in on the heating circuit open. Yeah, good question. Yeah.
Uh, someone asks, would a compact heat pump have been a better idea considering the small mechanical
Yeah.
space?
Yeah, I did consider a compact unit. Source their heat pump. It would be still really tricky to fit in because you need access around one side, or it would have been really tricky. The main constraint is actually the height. So this is only 2 meters, 2.1 something tall, and a lot of those units are taller, the more efficient ones. So the height was a bit of a constraint. Um, Cost and commitment to one system, at least with this, I can change the tank, I can change the MVHR, I can replace things, if stuff improves or I decide I don't like that type, I'm not as committed. So those are probably the main reasons. Yeah, bit of a not wanting to put all my eggs in one basket.
Do you know what the average COP of your heat pump is? I suppose that would be a seasonal
Exactly, yeah.
performance backed up.
Over all the time it's been running, it's 3.46.
Oh, impressive.
Since I made my changes in August, I've had some air problems, but I'm getting more like 4.3. But a lot of that has been heating season. So I think it's generally worse when it's just doing hot water, and it's running for
Hmm.
very short periods of time. So I don't know what the average will be, but I'm hoping it will go up.
It's been about four during the heating season.
Yeah, yeah, yeah. And sometimes on my best ever was 4.8 on one day, which is a hot water cycle, heating, and it likes sort of 1 to 2 degrees outside because that's running for quite a long period of time, but not too cold. So that's my
Impressive.
best ever day. Yeah,
Very impressive.
and the cylinder being quite not too empty. So
We've got about five questions left. I think we might be able to get through them all if we were able to hang on a little bit.
I'm
I'll be
happy to hang on. Yeah, yeah.
um I've got to go in about 5 minutes myself, but um the EPS, the external wall insulation, the EPS, is there any drainage against it underground?
Oh yeah, good point. Yes, there is. So there's a French drain, which is a pipe with some holes in it and some gravel on top, which sits right at the bottom of the EPS that comes down. So yeah, that all when the gravel runs all the way up the EPS. Yeah, so the picture I showed is actually mid construction where they just backfilled the little patio area, and we ended up digging a lot of that out again to by get that drain in, but also redo some other drainage. So
Okay, all right. What about overheating? Do you know what the overheating percentage was?
yeah, so I think shows on that PHPP front sheet. I think it's something like 1%. We haven't really got many windows.
Did, so
One.
did you, well, what they're also asking was, did you have to do anything to ensure you got that?
No, is the short answer. What am I on? Uh,
So you assessed it in the PHP
yeah,
and there was no measures you had to take.
no, because I face sort of southeast, but the main windows are very, very shaded. So my
Ah,
patio doors and my kitchen doors, the south side is a neighbour. There's a flanking wall. So the front bedroom is the warmest room because it gets sort of west sun. But then again, as soon as it starts to dip down, it's behind the neighbours. So I've got a very shaded site. And yeah, so it hasn't been an issue for me. The measures I've seen that I like are Bill Bordas's bedroom sheet outside the sash window. I quite like that as the measure. And yeah, but an opening windows, I think, is we're lucky to be able to do that, even though we're in a very central location.
someone is suggesting a phase change material, a PCM thermal store as an alternative for taking up less space.
The cylinder, yeah, my tank's small, but trouble is with that is you've got to get it upstairs. I've got to go upstairs, and the heat pump was bad enough. Phase change materials are heavy, so the tank's nice because you lift it when it's empty. We've never run out of hot water. It's 150 litres, I think, or the short one, I can't remember, or 120. We've got wastewater heat recovery on the shower, so which essentially means you've got more hot water because you're sort of using less of it. And if we've got visitors, we're running a tank at 47 degrees, but I could up it to 60, and that would be with the thermostatic shower, that would equivalently be more hot water. So yeah, there's a bit of flex there to go.
Okay. Did you do any Wi-Fi analysis? Did you feel you needed to?
No, I didn't. I think Woofy's useful for giving you a range of possible outcomes when you feel the risks greater than, particularly if you're exposed walls.
Hmm.
If I was pushing the internal wall insulation more, I would have done Woofy, or I would have thought about it. But the alternative is not to push the internal wall insulation more. So if
Hmm.
you're down at sort of higher U value than zero point 0.3, and
Yeah.
maybe if you're very exposed, a higher U value than zero point 0.4, then for me,
So
that,
that's where you were then. Was it U value of zero point 0.3 with your wood
yeah,
fibre?
well, you can see here. So I've got an average
Oh yeah.
internal wall insulation of 0.35.
Uh-huh.
So, and that's the record. So you want to be between zero point 0.3 and 0.35 is what the PHI recommend. In the UK, we normally say higher than zero point 0.4. Yeah, I've got one exposed wall. One side of my bay wall is a bit more exposed, but that's mainly window. So I think my problem's probably timber sash windows and making sure I paint my sills rather than water getting through the bung rouge. I've also got a rendered external, so it's not very porous. It's if as long as I keep painting, I've got a really good outside shell.
Did you consider having the rising? Sorry, did you consider the danger of rising damp in the wall when you got rid of the ventilated solum and replaced it with a slab?
Yes, so that's why I put this sort of perimeter down. I mean, this is all very unknown in a way. Let me try and find the picture. There, that one, bit loads. Um, So we left this gap, was it sort of 100 mil, and then the insulation, there's another layer of insulation. It comes up to the underside of that, and that's all filled with these beads. Um, so and they're a drain. It's like a sort of French drain. So the edge of the, there's nothing pushing against the edge of the foundation. At the front is concrete, so there is, but at the back it's got the drain, and we're on a big slope, and everything drains to the back. So yeah, I mean everything was very, very dry the whole time we were down there. Um, yeah, I don't really have much worry about that.
And one person says is asking why is there a reason why you used EPS rather than XPS below ground?
Um, I probably would have used XPS given the choice. Material availability is really difficult.
Mm,
So
mm,
XPS, the minimum orders are quite high, and we've
yeah.
actually got we've got a very small area. So even with EPS, I found it quite hard to find somewhere that would do the spec I wanted with the quantities, and we ended up with quite a lot of waste. So this board, you could buy one board, it was fine. Things like the XPS I wanted, there was a minimum order, which was way too much. So yeah.
Well, thank you very much. There's a question about how the bills compared, but I think you've already answered that in the presentation.
Yeah, I had a slide. I'll go back to it and leave it on that if you want. The numbers, one at the bottom there. So yeah.
Well, fantastic. Well, thanks again for such an amazing presentation. I'd love to see that again. I'm going to certainly watch it once it's because it's recorded. Thanks very much for your time, and what a great example to show everyone. Thanks very much.
Thanks very much, all. Cheers.